Swayam Prabha. Digital India. Educated India.
So we will now look at a game theoretic aspect of this. That is it beneficial for anybody to submit a false preference list instead of a true one? Okay, so does anyone have an incentive to submit a false preference list? So this is the question we want to address in this lecture and the next one. Okay, so we will assume a few things here. So let me write down our assumptions. So we will always assume that these preference lists are submitted to a central authority who is going to find out a matching after this. And we will also assume that the central authority is always going to run a man proposing stable matching algorithm or a man proposing Gale-Shapley algorithm. So there is a central authority that executes a man proposing Gale-Shapley algorithm. Okay, and in this case, is there an incentive for anybody to submit false preferences instead of true ones? So let's have a small example. So let me write down this example. Again, there are A's and B's. So there are 4 men and 4 women, and for the sake of simplicity, we will now again assume there are complete preference lists. So the case of incomplete preference lists is not very difficult, but to to focus on cheating and not on the difficulties with incomplete lists, we will just have complete preference lists and we will see what happens if someone submits a false list. So here are 4 men and their preference lists, and now we have 4 women. So meanwhile, you can start executing a Gale-Shapley algorithm and we will see what matchings we have, what stable matchings we have. Okay. So this is our example and we will see what happens. So can you quickly find a man proposing stable matching? So we will find out a man proposing stable matching, a woman proposing one, and then we will, in this example, we will see what happens if someone submits a false list and whether it is possible to benefit. So maybe I will find it out here. So A1 proposes to B4, and for now B4 accepts because currently all women are free. Now A2 proposes to B1, B1 also accepts. Now when A3 proposes to B1, we will have to see the list of B1, and B1 prefers A3 over A2. So B1 will break this engagement and will accept A3's proposal. And A4 proposes to B4. B4 prefers A4, so B4 will now reject A1 and accept A4's proposal. So A1 and A2 have to go ahead again. So now A1 goes to B2, and for now B2 accepts. What about A2? A2 also goes to B2, but now B2 will reject A2 because B2 likes A1 more than A2. So then A2 will go to B3 and B3 will accept. So let me mark this matching. So it is A3 B1, A4 B4, A1 B2 and A2 B3. And similarly for women, the same matching on the woman's side we will mark. Let's also quickly execute the woman proposing one, so that we have this as man optimal matching because this is men proposing, and now when women propose we will get a woman proposing one, which happens to be the other stable matching in this instance. So let's quickly do that. So now B1 proposes to A1, A1 accepts. B2 proposes to A3, A3 also accepts for now. Now B3 proposes to A1, and A1 rejects because A1 is already matched to a better woman B1. So B3 will have to go ahead and propose A2. So A2 will accept this, and then B4 will propose A4. Okay, so let me mark this matching differently. So this is the red matching is the woman optimal one. So for A1 it is B1, for A2 is B3, the same woman. For A3 we have B2, and for A4 we have again B4. Okay, so these are all true preference lists which they have submitted, and these are the main optimal and these are the man optimal and woman optimal matchings in the instance. Now let's see what happens if A1 changes the preference list. So instead of B2, B1, B3. So instead of this list, I will write a new list for A1, which A1 submits in the hope of getting a better partner, and let's see if that happens. So B2, B1, B3. Sorry, B2, B3, B1 is what I want. Okay. And now if you try to find out these matchings, it will turn out that only the man optimal stable matching remains the stable matching. Because A1 can no longer be matched to B2, but rather A1 always gets. I had not marked A1's other partner, which was this B1. So as it turns out, now A1 gets only B2. So the only stable matching with new preference list for A1 is the man optimal stable matching. And on the other hand, if we see what happens if B1 changes her list. So instead of this, B1 now gives a false list, which is A1, A2, A3 and A4. So with this we will find out the man optimal stable matching and we will see what happens. Okay, so once again we will execute Gale-Shapley algorithm with this new list for B1 but again the old list for A1. Okay. So now let's quickly again execute the Gale-Shapley algorithm. So again A1 goes according to his own list, that is B4 first, then A2 again proposes to B1, and when A3 proposes to B1, now B1 is going to reject A3. So this will be now a rejection. So A3 has to go further in the list and A3 has to propose B2. And when A4 proposes to B4, B4 will again reject A1 and hence A1 will go and propose B2. But then that proposal will not be accepted because B2 already has a better partner A3. So finally A1 will have to propose B1. Does it make sense? But what is this matching that we have obtained? Yes. This is man optimal, but for the original instance, this is in fact the woman optimal matching. So if you see, this matching is exactly same as this. Sorry, I missed B3 somewhere. Sorry, A1 proposes to B1. B1 will reject A2, yes. And then A2 goes to B3. Yes. So this is in fact the same matching as the woman optimal one. So one woman submitted a false list and hence instead of the man optimal stable matching, now the woman optimal stable matching has become a man optimal one. So now this instance has only one stable matching which happens to be woman optimal as well as man optimal. So if you see in the preference list, this red matching, the matching which I have denoted with red circles, it is better for women, all women, because they get better partners here compared to the other matching which was there earlier. So earlier when we executed the Gale-Shapley algorithm, we were getting this green matching which was of course better for men but worse for women. Now that matching has disappeared and only the red matching or the woman optimal matching has remained in the instance. So any questions so far? Is it clear what has happened? So she submits one woman B1 submits a false list and suddenly a better matching emerges for the women even though we are executing the same man proposing Gale-Shapley algorithm. So when we design a matching mechanism or an algorithm, we expect that it should be robust to cheating, or nobody should be able to cheat. As it turns out, stable matchings are not robust to cheating. It is possible to cheat. So in fact, a stronger result we can mention here. There is no matching mechanism that ensures both stability and truthfulness. Because if we get some other algorithm and we don't get to stable matchings, we will lose stability. On the other hand, if we decide to stick to stable matchings, this example shows that one can cheat there and get a better matching or a better partner. So in particular, B1 is now getting a strictly better partner in a man optimal matching compared to what she was getting with her true list. So in this example, when we earlier executed an algorithm where A1 submitted a false list, we saw that the woman optimal matching disappeared but the man optimal matching remained. So A1 really did not benefit because anyway the central authority is going to execute a man proposing algorithm, and A1 is going to get a man optimal partner anyway. So we will formalize this and we will now see one thing, whether men can cheat. So in this example, A1 could not get anything better. So if you look at the example for a while, A1's man optimal partner is B2, which A1 is anyway going to get with true lists. But can A1 ever get B4? So suppose A1 is trying to figure out a list where he is trying to get a better partner than the man optimal one. That is, he is trying to get a better partner than B2, which is B4 for him. Is it possible for A1 to do that with some preference order on women? Say it again. Correct. So no matter what preference list A1 submits, if A1 gets B4, then B1 is going to prefer A4 because still B1's list is the same. Similarly, if A1 gets B4, then A4 has to get something later in his list, because A4 is also right now planning to submit a true list, and anyway for A4 there is no incentive to submit a false list. He is getting a top choice. So if at all A1 somehow manages to get B4, then A4 B4 will form a blocking pair because both of them prefer each other over anything in their list. So here it seems that A1 can never get B4, or A1 can never get something better than his man optimal partner. And this is, sorry. So see, whatever preference list is there, whenever A1 gets B4, then A4 has to get something else, and A4 B4 will invariably form a blocking pair. So irrespective of A1's list, A4 B4 are going to form a blocking pair if A1 gets B4. So no stable matching is going to give A1 to B4, no matter how A1 forms his list. So as it turns out, it is not only this example, but in fact men have nothing better to gain compared to their man optimal stable partner. And this is what we will formalize in the rest of this lecture. So first we will address a simpler question. So here is the question. Is it possible? So see, again in the earlier example, we said that A1 cannot get B4 because for whatever reason, as in because A4 B4 form a blocking pair. But can all of them together cheat and get better partners than their man optimal partners? So is it possible for all men to get strictly better partners than their respective man optimal partners? So think about it for a while and just tell me what your feeling is. And if you think it is not possible, then why can we say that? Say it again, sorry. Yes. Well, see now, if all of them are submitting a false list, the new matching may be stable with respect to the new list and not with the old list. So all the men are trying to reform their lists and they want a better partner than their man optimal one. Now this matching may be stable in the new list, with the new list, but may not be stable with the old ones. Right? So yes. So it is not going to be stable with old preference list because old preference list already give the best possible stable partner to each man. But with the new list, can it be stable? Because it is enough for the men if it is stable with respect to the new list and if they get a strictly better partner than the man optimal partner with respect to old list. So once again, when they had the old list or their true lists, they were getting some partner which was man optimal for them. Now, is it possible to improve upon that? So by submitting false lists, so that when the central authority executes the Gale-Shapley algorithm on these false lists, that gives them a better man optimal partner than what they were getting with the true lists. It should be better with respect to old lists because old lists are their true lists. So what is the reason that you think? Yes, so what we will try to do is, we will look at the old lists and try to see if there is any matching at all. Forget about stability now. So with respect to the true list, is there a matching at all where every man gets a better partner than the man optimal one? If that is the case, then they can put those women as their first choices and the matching will be stable with those false lists. So let me write down the plan. So first we look at true lists and true man optimal partners of all men. And the question I modify as, is there a matching with respect to the true lists of men, and we will assume that women are not cheating for now. Now this matching will be possibly unstable with respect to these true lists, where every man gets a better partner than his man optimal stable partner. Yes, sir. This is the question. So let me again write down a small instance. So suppose the picture is like this, so, and something, or maybe here B3. Then we have A2. So I will not write the women's list for now, but suppose the man optimal stable matching turns out to be something like this. So B2, B1 and this is B3. Now here the men figure out that for each of them the better partners are B1 for A1, B3 for A2 and B2 for A3. Okay. So suppose the women's preference lists are such that this matching is not stable. But then they can make this stable by transforming their list to something like this. So A1, B1, and whatever he puts doesn't matter. A2, B2, sorry, A2, B3, and A3, B2, and then whatever they put. So if they change their list from here to from this to this, then they are not going to form a blocking pair, because as soon as they propose the first woman in their list, they are going to get matched. Okay? Because all men have separate women in their list, and now they really don't have to worry about blocking pair, because this matching is certainly going to be stable no matter what the women's lists are. So the real question to answer is, whatever the man optimal matching here is with the two lists, is there a better matching at all? Or is there a matching where every man gets a better partner at all? If at all such a matching exists, like this circled one, it is easy to make that matching stable by submitting false lists. Just put all those partners as the first choices of respective men. So what we will show is that there is no such matching at all. So this B1, B3, B2 may not be stable, but it's at least a matching in this instance. We will say that this circled matching actually doesn't exist, neither stable nor unstable. Which also says that it is not possible for all men to get better simultaneously. Is the question clear, or is there a confusion? There is no such matching at all. That is why I cheated by not showing women's lists, because otherwise it would have turned out that these B2, B1, B3 cannot be man optimal partners. So this is really a hypothetical example where I showed their man optimal partners and said that it is possible to get better. If that is possible, then they can make that matching stable by going to these new lists. But there is no such matching at all. So these B2, B1, B3 cannot be their man optimal stable partners. So we will formally prove that there is no matching, stable or unstable, where every man gets a better partner than the man optimal one. So we will say that this cannot happen. So now let's again look at how a Gale-Shapley algorithm is executed on a given instance. So I don't have a specific instance right now, but assume that we have an instance which has some n men and n women, and there are complete lists. Okay. Now Gale-Shapley algorithm goes on, and one by one men and women pairs are formed. So finally, when does the algorithm terminate? So just look at the point where the algorithm terminates. So when does that happen? Exactly. So when all men and hence all women get their partners, the algorithm stops. So there must be a last man-woman pair which gets formed when the algorithm stops. Okay. So look at the last woman who gets engaged. So let's say B is the last woman to get engaged. And let's say she gets engaged with A. But then, is it possible that she would have received proposals earlier? So, see, she is the last woman to get engaged, which means all the women are engaged before her. But then she would not have received any proposal before, because as soon as she receives the first proposal, she gets engaged. A woman never rejects a proposal if she is free. Okay? So, if she is the last woman to get engaged, that means this must be her first proposal. If she had received a proposal earlier, she would have accepted it because she is free. And once she gets engaged, she only gets a better and better partner, but she never gets free again. Right? So by the property of the Gale-Shapley algorithm, once a woman accepts a partner, she can only reject him for a better partner, but she will never become free again. So if the last woman, until the termination of algorithm, she was free, that indeed means that she never received a proposal so far, and once she receives this first proposal, the algorithm stops. But that means B never rejected anyone. So B gets only one proposal, and hence does not reject anyone, or rather does not get a chance to reject anyone. And now let's say the main optimal matching is M naught. And suppose M is the matching which is unstable, but every man is better in M compared to M naught. So we are now comparing two matchings, M naught which is the man optimal stable matching, and M which we said is a matching where every man gets a better partner, but the matching happens to be unstable. Okay, so let me just draw this. So B is the last woman to get engaged in M naught, and B gets engaged to A. So AB is a pair in M naught. Now what happens in M? A must be getting a better partner, right? Because our condition is that in M every man gets a better partner. So A must also be getting a better partner. So A must be getting some B prime where A prefers B prime more than B. And similarly, this woman B, she must be getting some partner still, because M also should be a matching which matches everybody. So suppose some man A prime gets now matched to B. Now, okay, so let me draw them in a continuous fashion. So here is A to B, and this is our M naught matching. Now B gets A prime in M. So M matching I will show with plain edges and M naught with zigzag edges. And A gets B prime. Now clearly A prime prefers his M partner over M naught partner, because again in M everybody gets a better partner. So A prefers the matching M. So clearly B should prefer the matching M naught. Right? Because otherwise his A prime B pair forms a blocking pair for M naught. So now B should prefer the matching M naught. But then what happened when we were executing a Gale-Shapley algorithm and A prime proposed B? Why should A prime propose B? Because A prime is matched to someone in M naught, which is a B double prime. So now what should it be for A prime? So every man prefers his M partner. So A prime also prefers B, with whom he gets matched in M, over his M naught partner B double prime. But then in the Gale-Shapley algorithm, A prime must have proposed B before B double prime. So how does the Gale-Shapley algorithm will execute? A prime's list must be B and then B double prime. Is it clear why? Because in the matching M, every man gets a better partner than what he gets in a Gale-Shapley algorithm. So in the matching M, A prime is getting B, which should be more preferred over what he gets in the matching M naught, which is B double prime. But then A prime must have gone in the order of his preference list in the Gale-Shapley algorithm, and he must have proposed B at some point. but then B is matched to A, so B must have rejected A prime's proposal. But then our observation was that B gets only one proposal and B does not reject anyone. Is everyone with me? So the last woman who gets engaged, she could not have received two proposals, but here it seems that A prime must have proposed her before going to his man optimal stable partner, and she must have rejected that because she is matched to someone else in the man optimal matching. But then she could not have rejected anyone, so such a matching M should not exist. So the matching M just cannot exist. Yes? Yeah, so this is a nice observation, and yeah, this should happen for someone in the course of the algorithm. Yes. So here we have ruled out that there cannot be a better matching for all men compared to the man optimal stable matching. So all of them cannot come together and cheat in whatever way to get better partners. The next question comes, is it possible for some men to come together and get better partners? Okay, all of them cannot get better. Can some of them get better by cheating or by submitting false lists? So the next question we address. So here let me just write down our observation. That all men cannot get better partners. And now we ask the next natural question, can some men get better partners? Or in particular, can one man get a better partner compared to his man optimal partner? So now the next setup is, some men are really the cheating types. They are going to submit false lists, and they want that once they submit this false list and all other people submit true lists, the instance actually admits a stable matching which is better than the original one for these people. So once again we want to show that this cannot happen. So the nice thing about Gale-Shapley algorithm is that there is no incentive for men to cheat. So this is what we will prove now, and it will turn out that if we are using a man proposing algorithm, men cannot cheat. So let's say it is possible. So for the sake of contradiction, suppose it is possible for some men to get better partners by submitting false lists. The central authority has no way to know whether the people are submitting true lists or false lists. So whatever lists are given to the central authority, the Gale-Shapley algorithm is going to be executed with those lists. So we will see what happens. So let's say this X is a set of men who get better partners. When I say better, it is always compared to the man optimal ones when they submit true lists. By submitting false lists. So this is the whole set of men. This is the whole set of women. And there is this set X. So these are the men who cheat, and this is exactly the set of men who get better partners. So the remaining men may get same or worse partners, we don't know. But nobody else gets a better partner, only the men in X get better partners. And we will see why this cannot happen. So once again, assume that this M0 is a man optimal stable matching. With true lists. And M is a matching where X get better partners. When I say X, I mean every man in X. So first of all, look at these men in X and see what they were getting in M0. So let's say they were getting Y in M0. So Y is the set of M0 partners of men in X. So in other words, Y is the set of women with whom men in X get matched with true lists or in M0. Now we want to say that there is this supposed matching M where X get better partner when the central authority executes a man proposing Gale-Shapley algorithm with their false lists. Now we want to say that this matching cannot be stable, and we want to show a blocking pair where there will be some A here and some B somewhere, maybe in Y. So we want to show that this is a blocking pair with respect to M. So this is our goal. So men in X they are trying to get better, and suppose they can get better in the matching M, but then we are showing that even with their lists, with the current set of lists, there is a blocking pair. Sorry? Why is M not X? So they are man optimal stable partners. So in M they may get some other partners, and that set may be different. So right now I have not used Y in any way, I am just stating the goal. So the goal is that we want to exhibit a man-woman pair which forms a blocking pair with respect to M. And also what is important is that we don't want this man A to be in X. So this man A should be outside X. So man A is submitting a true list and this woman B is submitting a true list, because women are all submitting true lists. So if this is a blocking pair, then this matching M cannot be stable even with respect to the false lists of X, the men in X. With true lists, it is anyway not stable because it gives better partners than the man optimal ones. But even with the false lists of men in X, this matching is not going to be stable. So once we show this, we will have shown that there is no such matching M which is stable at least with respect to the false lists of the men in X. And hence there is no such set X where men can submit false lists and get a better matching for themselves. So any questions so far? The true and false list may be a bit difficult to visualize, but say it again. Yes, so we will prove it. So this is currently only as our goal. So goal is to show that there exists a blocking pair with respect to this matching M, and what is important to show this blocking pair is that this man A is not in the ones who get improved or who get better partners or who submit false lists. No, we will rule out that some men can get better partners, because even if these men in X submit a false list, there is no such matching M which is stable with respect to the false lists, because there is a blocking pair. That too, the blocking pair comes from the people who are submitting true lists. See, with respect to M0 is not a problem, right? Because once they submit a false list, there is no way for the central authority to know whether the matching is stable with respect to true lists. But even with respect to false lists, there is not going to be a stable matching which gives better partners to X. So once someone falsifies the list, it may be possible that the new matching is unstable with respect to true lists, but is stable with respect to the false list. But even that is not going to happen. Even if they submit false list, there is no matching M which is going to be simultaneously stable with respect to the false list and giving them better partners with respect to the false list. So let me just take this figure ahead. Okay. So here we consider two cases. So we said that the men in X who are getting better, they get the set of women Y in their man optimal stable matching with respect to true lists. So just to recall, M0 is man optimal with respect to true lists. And X is the set of men getting better partners this new matching is M with respect to false lists. Okay. So now the men in X are getting the women in Y whenever they submit true lists. Now what happens when they submit false lists? So we want to divide two cases. We want to divide this into two cases here. So let me remove this, and for now I want to remove this as well. So let's get to the original picture. Well, I have not written much. So this is the set Y and this is the set of women. Okay. So now there is so we want to see two cases. One is either every every woman who may get matched to men in X exactly comes from this set, or there is a woman outside this set who gets matched to a man in X. So let's say the picture is like this, and this man gets a woman B in the matching M. So the man A was getting some other woman B prime when he submitted true list, and he was getting B prime in M naught. Now in the matching M he is getting B, and clearly because A is in X, we know that A prefers B more than B prime, because he is one of the people who is getting better. But then who was B's M naught partner? So let's say in M naught, so these blue dashed edges give the matching M naught. So B was getting, suppose, a partner A prime in M naught. So A prefers B. So now when I say A prefers B, that is according to true list, because A really has his own preferences in mind so that he can cheat. And now what should B's preference be between A and A prime? Yeah, so B should prefer A prime, otherwise AB will form a blocking pair with respect to this matching M naught. So A prefers B over B prime, therefore B should prefer A prime more than A. Otherwise AB blocks M naught. So now this man A prime, he is not in X. So if he is not in X, then he is not going to get better in the matching M. So A prime also gets a worse matching M. And so does B. So A prime B blocks the matching M. So this is really the first case where we said that there is some woman B outside this set Y with whom a man in X gets matched in the matching M. So let me write down this particular case that we considered. Case 1, there exists a woman B not in Y such that some A in X gets her in the matching M. So the set of men in X with their two preference lists were getting the set Y. Now if one of them gets something different from the women in Y, then what happens we have seen. So one such man who gets something different from the women in Y, let's say this woman B in the matching M, then he should prefer this over the woman B prime, because he is trying to get a better partner in M compared to M naught. So A prefers B, therefore B has to prefer the M naught partner, otherwise they will form a blocking pair. Now can A prime be in X? I mean, I have drawn it here outside X, but can A prime be in X? So why not? Maybe he gets a further better partner, but then the reason is even more basic. So why is B outside this set Y? So if A prime was in X, B is his M naught partner, so she would have been in Y. But because she is not in Y, her M naught partner is not in X. Okay? So just by the definition of the set Y and definition of the set X, if A prime was in X, by definition of Y, B would have been in Y. But just we said that there is some woman B not in Y who gets matched to some man in X in the new matching M. So then her M naught partner cannot be in X, he has to be outside. But then X is only the set of men who are getting better. So A prime must be getting a worse partner now, but B is also getting a worse partner. So A prime B form a blocking pair with respect to M. So let me just write down this reason because it is not completely straightforward. So the M naught partner of B, which is A prime, and A prime is not in X because B is not in Y. So A prime gets worse in M. So A prime gets worse, B also gets worse. So they two together block M. So even with the false preference list of men in X, M cannot be a stable matching with respect to even those false preferences. Because everybody else is submitting two preferences and they are going to form a blocking pair against this matching M.